Good morning, everyone. Welcome and thank you for joining us for Teledyne ISCO's August Water webinar. Today's webinar is an Ask ISCO session focused on portable sampling. This presentation is being led by Jeff Vandehoef, one of Teledyne ISCO's product support specialists. If you have any questions or comments during the webinar, please utilize the chat function within the Zoom platform, and all questions will be answered at the end of the presentation. This webinar is being recorded and will be available for registrants and attendees through Teledyne ISCO's YouTube channel later on this week. And at this time, I will turn it over to Jeff.
Hi, everybody. Again, my name is Jeff Vandehoef, like Tori said. I am a product support specialist here at Teledyne ISCO. I have, close to 30 years experience here at Teledyne ISCO. Last 5 years, I've been in the product support services group as again, a product support specialist, pretty much answering phone calls, questions people have about applications, all that kind of stuff. I actually have made a whole bunch of site visits to sites. They'll send me out sometimes if customers need help with training, all that kind of stuff. I'll actually go on site and do all that stuff as well. That's what I've done in the last 5 years. The last 15 years, I was actually in service, so I have real good knowledge of actually working on equipment and everything like that. I've seen lots of different equipment come in through the years. What we're talking about today is going to be our portable sampling units. We have different sampling units that we use for portable versions. The first one, the oldest model we have available, is our 3700 and 3710 sampler. That one we have available in a compact version, which is just a smaller radius, smaller diameter, a little bit shorter unit too. Makes it a little bit easier to put in manholes or carry and move around. We also have a 3710 version that comes in as standard and compact. The difference between the 3700 and the 3710 is the 3700, you can have multiple bottles in the configuration, anywhere from 2 to 24. And in the 3710, you can have just one bottle in that configuration. All the programming and everything like that is the same in both, but you're just limited on the bottle numbers on that. So the next one, the next sampler we have is our GLS sampler. That is a compact, composite only sampler. It is just one bottle. You can't do multiple bottles on that. It's our smallest, most inexpensive unit, but it's a very good unit. The next one we have is a 6712. Again, that one's available in our compact and standard sizes. That one can range from 1 bottle to 24 bottles, a whole bunch of different composites.
Jeff, I think we're having some technical difficulties. We're not seeing the slides progressing.
Yeah, I have not advanced one yet, so.
Oh, okay. Just wanted to make sure. Thank you.
I will when I get to the questions, but yep. So, the Avalanche and the Glacier are our other 2 portable models that we have. The Avalanche is it's a refrigerated unit, so it's a portable refrigerated unit. You can run it off of AC power, you can run it off of DC power. The other refrigerated portable one that we have is the Glacier unit as well. The Avalanche has basically the same function and controller as the 6712, and the Glacier has pretty much the same controller and functionality as the GLS sampler. So that's just a basic overview of what samplers we have and just a little bit about their options. So what we'll do now is we'll actually get on to the questions that everybody submitted earlier. So the first question, which portable sampler do I choose for my application? That's a hard question. Pretty much any sampler we have will probably work for your application. What the main thing you probably want to decide is, what do I need for that application? Do you need remote telemetry? Do you need, to trigger it with a rain gauge? Do you need multiple bottles? Do you need single bottle configurations? Those are the major, factors that contribute to which sampler you pick for your application. Again, so if you need multiple bottles, well, you probably have to go with a 3700 or a 6700 or an Avalanche. I guess if you want refrigeration, then you probably have to go with either the Avalanche or the Glacier. So it's basically depends on your need. Like the 6712 actually has like remote communications, and it also can have like a sonde, YSI sonde, which has like SDI 12 input to it. So if you want to trigger based on pH or dissolved oxygen or something like that, well, then you would probably have to go with the 6712. So again, yeah, it's probably more, any sampler will probably work in your application to get sampler, sample, but just the extras are probably what you really want to focus on when you're choosing a sampler. Next question we got is how do we sample VOCs with a portable sampler? So VOC, what that stands for is volatile organic compounds. We used to have a sampler back in the day. Like I said, I've been here 30 years. It's probably been 15 to 20 years ago. We used to actually offer one of those in a portable version. We do not any longer actually have one of those. So we do not have a VOC sampler, for portable version or even for a permanent refrigerated versions. We discontinued that quite a while ago. The next question, in sampling within a plant for process control on a short-term basis, what is the most economical sampler to use? So the most economical sampler we have is the GLS sampler. It's a smaller, lightweight one. It's designed to be moved around easier. It's designed to, it's very good for as energy efficient. The battery lasts a lot longer with the GLSs too, a lot less current draw. There are some limitations like on head height and stuff like that. Like the 6712 will have a little bit higher head height and everything on that. But the GLS is usually one if you're moving around a lot and it's just going to be a temporary study. That's probably the most popular one, and it is the cheapest one we offer as well. What are the most common sampler applications? So probably the most common that we see are probably influent and effluent to like a wastewater treatment plant. Next common we see like processing, like the question before, like, in process sampling. So they want to see what the water is doing at this process in like a manufacturing plant or something like that. And yeah, another common place we see it is any type of manufacturing plant that discharges water into like the town sewer system. We'll see monitoring there as well. That's a very common application for it too. We also see like stormwater monitoring. People will, set up a sampler maybe in a dry creek bed or a channel. When it actually rains, we can actually start the sampler and trigger it to start taking samples when we see the rain, when we see water, when the channel actually gets water in it. Other applications, process control there. Yeah, those are probably the most common applications that we see on there. See lots of different types of applications, everywhere, but yeah, those are the most common. Again, simple unit best price, that is going to be the GLS, but again, it depends on really what you need. If you need peripherals, if you need a higher head height, if you need stuff like that, you may have to go with, different units. So, on here, let's check the chat, make sure we're all good. The next most common unit would probably be the 3700, 3710 series. That one, you can do time-paced, flow-paced programs. There's a little bit more to the programming on that one, a little bit of options. We have enable, disable options where we'll disable the sampler until we actually get water through the channel. Once we get water through the channel, then that will enable the program, boom, let it start taking samples and everything like that. The next one up is the 6712. 6712 is like our highest, most functioning unit, again, where you can do YSI input. It has telemetry where you can have modems and everything hooked up to it. And then past that is the glacier and then the avalanche for order of price. The next questions are based on operation and actual mechanical questions on the samplers. First one we had is, how does a sampler actually work? So all of our portable samples are actually peristaltic pumps. How a peristaltic pumps works is there is a paddle that's in the middle of the pump housing. The paddle spins and actually pinches the tube up against the outside of the pump housing or the band, according to which sampler you have. When it pinches that tubing, it actually moves air through the tubing as that paddle spins, and that either creates pressure or suction in the tube, depending on which direction the pump is actually rotating. So when it runs in the forward mode, we're actually sucking water up to the actual unit. Once the water actually comes up to the unit, then we have a liquid detect sensor there. Once the liquid detector sees the water right there at the sampler, then the unit says, oh, I have water there. Now I need to start counting how many pump revolutions I need to get whatever your sample size is. If you want 100 mils, 200 mils, 500 mils, and that's all user programmable, in the unit. So, how does a sampler know how much water it is actually sampling? Well, that goes along with the liquid detector. When the liquid detector sees liquid, again, that's when it starts counting the counts that it goes. So the water hits the pump, and then it knows, it has charts and tables built into the sample that says, okay, I need to do 10 revolutions of the pump to get 100 mils, or something like that. One little other piece on that of actually how the liquid detector works. So when the water actually hits the liquid detector, the tubing that's actually in the pump, when there's water in it, that tubing, it's like a soft, squishy type tubing, it actually expands and contracts with the pump paddle spinning. And when that tubing actually expands, what it does, it presses on our piezoelectric sensor, which is our liquid detect sensor. When it presses on that sensor, it makes a voltage, the voltage that the sampler can actually recognize. So we have to have that tubing expanding and contracting. When it expands, it pushes on the sensor, we get a voltage on there. So next question. How can I handle the drifting of distributor arms? You should never have any drifting of the distributor arm on any of our portable samplers. All the portable samplers, the ones that actually have distributor arms, it's the 3700 and the 6712, and then of course the Glacier. All the other ones do not. 3710 and the GLS do not have distributor arms. The distributor arm mechanism in those units, in our portable units, are actually locked in place. So it moves from one to the other, and it's always locked in place, when it stops. You should not ever be able to move the arm or rotate the arm. My guess is maybe what they're talking about is our 5800, 4700 arm. That one, in between samples, the arm can drift over different bottles. But when that one actually powers back up, it will actually lock in the position over the bottle whenever it's taking a sample. So you may get a little bit of drift after on those, but that's the nature of how it works. You will get a little drift on them. But all our portable units, you should never get any drift. If you are getting drift, then you may have a problem with the actual unit. So. Next question, can the arm be calibrated to ensure it is staying over the sample bottles throughout the entire sampling program? Well, that's kind of just covered that in one before. Again, it should always be over there, and it should not drift in any of our portable samples. So, maintenance questions. What type of maintenance do you need to do with the portable samplers? The main maintenance that you do have to do is change the pump tube. And I always note you want to change the pump tube before it breaks. Over time, you're squishing and you're compressing and contracting that tubing, and over time, you know, it will develop a line or a hole or a rip in the tubing. It all does it. It will all develop that rip over time. So what you want to do is you want to change it before it actually breaks. If you change it after it breaks, sometimes it can clog up the housing and you can force water actually into the sampler, and it will actually, you know, ruin the sampler or get water damaged inside the sampler. All of the units actually have a counter that's built into the unit. The counter counts up the pump revolutions of each sampler. Every time the sampler actually runs and spins the pump, you know, it counts those. So you may see a warning come up on the screen of the units that says, you know, warning, replace pump tube. At that point, you really want to wash the tubing. You want to make sure that you want to get that tubing replaced before it breaks. Because like I said, it can, you know, water damage the unit. And then when you replace the tubing, then you want to go back in and make sure to reset that counter. And you can reset that counter on all the different units. So. The next maintenance thing I like to do is, like, every time I change a pump tube, sometimes you can get like a sticky film built up on the rollers inside there. Sometimes you can get dust and debris built up in, actually, you know, make the pump tube last not as long. So every time I pump, I make sure that we clean that housing out. Really don't need any special tools, just the damp rag is pretty much all you need. Wipe everything out, make sure all the dust and debris is out of it. Another thing is the desiccant. All the units actually have desiccant in there. The desiccant actually absorbs any moisture, any small amounts of moisture that can get in the unit. All of the units have a little window, and there's a little humidity indicator, a little round humidity indicator on the front of all the units. When it's shipped out brand new with good desiccant, you know, that little humidity indicator should be blue, or about 3 different shades of blue actually, in each little triangle that it's divided into. When you start seeing that getting, you know, pink or even going start to white, you know, at that point you probably want to open up the unit and change the desiccant out of there. There are different size desiccants that go in each one of the units. All of that is, you know, actually available on our website, teledyneisco.com. You can get all the different desiccants and everything from it there. And that's about it for maintenance. Next one, how can I prevent or handle clogging in the intake tubing? So the intake tubing is the tubing that actually comes off of the sampler and then goes down to your source. We usually have like a strainer or something on that. It's basically like a little pipe, or a plastic pipe or metal pipe, and it has a whole bunch of holes drilled into it. So it kind of filters out any big rags or big debris or anything like that, big rocks, all that kind of stuff. That sometimes will get clogged up. It either gets ragged up. Sometimes there's sediment in the water. You know, sometimes that can settle out and actually settle over the actual strainer. So, you know, if you have a lot of rags or if you have a lot of sediment in there, you can probably build like a diversion structure, like a wedge or something like that, and put it in front of the actual strainer, where you actually put the strainer in the water, and that will kind of deflect a lot of those big particles or rags or anything like that from catching the strainer. That's probably the best ways to do it, is to have some type of diversion structure. Also, when you do a purge, it actually will blow some of the sediment out of there. So if it does get in sediment, it actually blows bubbles out that strainer on the purge cycle. So sometimes that's enough to clear out any debris or something that's on there. If that's not enough, then again, yeah, you have to do the diversion structure, or maybe mount it up a little bit higher in the stream, left or right, you know, just places that don't tend to get the debris or clogging. So. And the next one are on batteries. So typically at battery life, sorry if we're cutting out there, what we usually get is about 100 samples out of one of our NiCad or one of our lead acid batteries. The NiCad and the lead acid are our two most common type of batteries that we use. When we say 100 samples, that's kind of a typical routine of we take a sample every 15 minutes and, probably 10, 15 foot of suction line and like no rinses or retries or anything like that on there. You can pretty much always be happy if somebody's asking you how many samples you're going to get. You can just say 100, and you'll pretty much always get 100. Times where you won't get 100 out of the NiCad and the lead acid is if like you're taking a sample every minute or every 2 minutes. At that point, it will actually basically it's like a current draw all the time on the battery, and the battery just won't last as long on those. The sampling routine itself can take anywhere from a minute to 2, 3, 4, 5 minutes, something like that, depending on your suction line length, rinses, and all that. So yeah, if you're doing rinses, all that, retries, you're going to get probably less than 100 out of that. The main factor really is just the length of your suction line. We can go up to 99 feet on the suction line. Typical, we see anywhere from 10 to 25 is our most common that we see on that. The difference between the NiCad and the lead acid, the NiCad is a smaller capacity battery. It's around 4.5 amp hours, and the lead acid is a little bit higher capacity battery, and that goes to about 6 amp hours. The NiCad, they're a little bit more durable as far as charge and recharge cycles, but the lead acid, they just get more power out of it. You can get more samples out of it. The next question is there any way to make sure the battery is charged? We like to leave them on the charger for 16 hours. 16 hours is the minimum, to achieve a full charge on the battery. 24 hours is the max. You don't really want to go over 24 hours because that can start damaging the actual battery itself on there. So at least 16 hours before you're going to deploy them, that's when you want to take them off the charger. If you actually want to measure the voltage on the lead acid and the NiCad, about 12.5 volts DC is the full charge on a NiCad, and about 13 to 14 volts on a lead acid is a full charge on that one. So the next question here. Can you give recommendations for portable samples on ephemeral streams in the Southwest that receive most of its precipitation during the summer monsoons? So in any type of remote application like that, where you're only powering off a battery, our NiCads and our lead acid probably are not going to be your best choice for a battery on that. What we usually recommend in that case or them circumstances is like a deep cycle marine battery. Those are usually like 100 amp hour marine battery. You can get those at like your local hardware stores, Menards, Home Depot, that kind of stuff. Auto stores, they sometimes offer them for like your campers and stuff like that. You're going to get a lot more life out of it, a lot more samples, out of one of those. And it's going to last, months out in the field as it's waiting to take a sample. Also, what we usually recommend is some type of solar panel to put on there to actually trickle charge and maintains the charge on the battery. Once it, then when the sampler actually starts pumping, usually it's too much for a solar panel to help, but it actually, at least you start with a fully charged battery at the end of that. So yeah, 100 amp hour marine battery and, probably at least a 40 watt solar panel would probably be what I would recommend in that application. Again, if you're not sure if it's going to be big enough, I always err on the side of caution and go with the bigger panel and the bigger battery. So. Next section is about programming and operation of the actual unit. This section we get into a little bit of programming options, enabling, disabling samplers, that kind of stuff. First question is, can the 6712 be activated for a certain flow range? Yes. So the 6712 is capable of actually having its own flow module
in the unit. There's a little cavity, a little cutout in the side, and you can actually buy a flow module that goes in there. There are 3 different flow modules that you can have in there. It's 720, which is a submerged probe flow module. You can have a 730, which is a bubbler flow module. And then you can also have a 750, which is an area velocity flow module. Any one of those will actually give you a flow rate on there. And you can say, okay, when my flow rate gets above 10 gallons a minute, then you can say enable the sampler, and it'll actually start, sampling. You can do a range. You can say if it's between this range, that's when I want to run it. There's different things. You can sample off enables and disables. A whole bunch of different stuff on that. But yes, the 6712 can actually be activated off of flow range. Can also be activated off of if you have another flow meter that's in the device, a non-ISCO flow meter or a different separate flow meter. We have interface modules and stuff that will go between the separate flow meter and the 6712, and you can enable and disable the program based on all that stuff. And actually all of our samplers have that option to enable and disable and say, okay, when my flow hits this, enable the program in the sampler and start actually running and collecting samples. So not only just the 6712, but all of our samplers actually have that capability. So next one, can you run 2 portable samplers at the same time off of 1 flow meter? So yeah, you can do that. There's a bunch of different ways to do that. You can, the first most common one that we see is probably a contact closure. We have a cable that you can get from us, basically, and there's 2 wires that come off the cable. When you take and short those 2 wires off of our cable together, that counts down a flow pulse on the actual unit. Every time that flow pulse count downs, it takes a sample. If you want to do 2 at once, you can just parallel those 2, the contacts. So you'd have 2 cables, 1 cable that came off of each sampler, then you would put, I think it's a red and a green wires, you just put the 2 reds together, the green wires. I'm not positive on the colors there, but yes, you can do that there. We also have ways of, we have like telemetry with the 6712, where you can enable one sampler based off the rain, and once that program is enabled, well, it can send a text to a different 6712 that has a modem as well and says, okay, the rain is here, you want to start your program as well. So there's lots of different ways we can do it. Another way, another common way is a 4 to 20 milliamp signal. We have a 4 to 20 milliamp module that actually will screw onto the 67 or any one of our samplers. And that takes the 4 to 20 milliamp sample, which is a flow signal from a flow meter. And it monitors that 4 to 20 milliamp signals, and it converts it into gallons or whatever, and it says, okay, it will take a sample after it gets, so many gallons of water goes by. And if you wanted to do 2 samplers, what you do is just make a series loop with the 4 to 20. So kind of like if you're hooking 2 batteries in series, you have to do positive to negative, positive to negative. Same thing here with the 4 to 20, you have a positive and negative, you just do positive, negative, make one big loop with whatever's generating that, whatever flow meter you're getting that signal from. Yeah, so a bunch of different ways you can do that, more than one. We also have like a Y cable that will come off one of our older 42 samplers. That one, the Y cable goes and just duplicates the flow pulse to both units. If you're talking our newer flow meter, we have 306 modules. And with the signature flow meter, you just have to have 2 306 sampler interface modules, and you can go off of the same flow rate and everything, and they should sample, relatively the same time. So next one is how do you verify that the samplers were kept cold? So with our Avalanche and our Glacier sampler, those are actually portable, battery-operated, refrigerated samplers. Each one of those actually generates a report of the temperature. In the report, it'll actually say your minimum temperature, it'll say your maximum temperature, and then it'll have an average temperature for you. And that's all available in a report, and you interface that using the display of the keypad. Also, on those two samplers, on the Avalanche and Glacier, there's actually on the display, when it's actually taking a sample and doing a sample routine, the screen kind of rotates between 2 or 3 different things. And one of the screens that goes there, it actually tells you the temperature that's inside the refrigerator at that time. So you can actually see, what the temperature is, just by watching the display. And then again, also, your reports. So. Next one, I need to trigger multiple pump samplers based on a precipitation threshold. Can I do this with one rain gauge? Yes, you can do it with one rain gauge. The sampler that you would have to use would be the 6712. The 6712 is our only sampler, the 6712 and the Avalanche are our only 2 samplers that actually will work with a rain gauge. Again, you'd have to have 2 cables that go to each one of the samplers, and then you can take those wires and parallel them on the rain gauge, and then so every time it tripped the rain gauge, it would send a pulse to both samplers. And then you set up the 6712 with the Avalanche to say, okay, after I get so much rain in an hour's period, then you start the program and you start sampling. You can also do it event pace too. You can say every half an inch, take a sample. You can do all sorts of that stuff on there. Also, like I said before, you could have you could have a trigger one sampler, and then if you had modems on both samplers, you can have the modem send a message to the second one if they're not in the same location. So yes, that is capable of doing that. Is there a way to use one of your flow metering devices with the 6712 to minimize the use of confined space entry permits? So what they're talking about there is we have flow metering inserts. It's like a round barrel-shaped thing. It has like an inner tube on the outside of it. That inner tube, you shove that all device into a pipe, and you expand out that inner tube, and that presses against the side walls of the pipe. And then in the middle of that device, there's like a V-notch weir, and they use that to measure flow. So you take that, and we have a tool that we can use. It's like a street-level insert tool, and you can actually, it's a whole bunch of poles you hook together, and then you can lower this thing down, and then there's a cable that you can use to either, if you can use a spring ring or the street level or the flow inserts, and you just take it and you put it in the pipe with a pole, long pole, and kind of an angled bracket on the end of it. So yes, the 6712 can be used that. You have to have the flow modules with that. And when you set up the programming for the flow modules, one of the options, so you either select your weir or your flume, which is typical. One of the devices that you can set is our flow metering inserts. That'll be one of them in there. There's different sizes, 4-inch, 5-inch, 6-inch, all that. There's different sizes. And you just select what size you have for what pipe. So yes, you can do that with a 6712 and a flow module. Can you discuss the use of discrete sampling? So by discrete sampling, what we call that is just multiple bottle sampling. So we can have, with the 6712 and 3700 and the Avalanche, you can have multiple bottles. One of the most common one we see is a 24 bottle system. You can set up the unit to, let's say, you want to set it up for a 24-hour period, and you want to take samples, one sample an hour, and you want to put it in, each individual bottle. That's a very common thing that we do. So this sample, this is at 12 o'clock, 1 o'clock, 2 o'clock, and all the way for 24 hours. So, your first bottle took place, at the first time stamp, and then an hour, after that. We can also do like kind of a combination of composite slash discrete sampling, where we can say the bottle sizes for the 24 bottle system are 1,000 mils. So you can say, I want to, every time it takes a sample, or you can say, I want to put more than one sample in each one of those individual bottles. So, 3 or 4 times, you could say, let's say you put 300 mils in, 300 mils in, 300 mils. Then you can say, okay, then move to bottle 2. Does the same thing, put 300 mils in 3 times. And then at the end of the whole times, you'll have 900 mils in each one of the bottles. You can do any combination like that. You can do bottles per sample. So let's say you want 2,000 mils as your total at the end. Well, then you say, so you do bottles per sample, and so you would say 2 bottles per sample. So every time it took a sample, it would put water in, fill up the first bottle, and then fill up the second bottle, and then move to the third bottle and wait for, its trigger to take a sample on the next set. And then again, you do that all the way through all 24 bottles. So yeah, we have multiple options on there, and again, it's the 37, the 67, and the avalanche are the ones we can do, discrete sampling on. So, and miscellaneous questions. Can you discuss installing the 6712 sampler? So the main thing you do when you install the sampler is you have a suction line that goes and hooks onto the unit, and that suction line runs all the way down to the source. You want to make sure to anchor the strainer or the end of that suction line in your source so it doesn't float above water and everything like that. The 6712 has covers and everything like that you can put on there that covers it from, rain and wind and the sun and everything like that. You want to make sure you install that cover on there. When I'm putting it in there, I try to find a spot that's as close to the water as I can. Like I said before, the longer your suction line on there, the longer it's gonna, or the less number of samples you're gonna actually be able to take. So I always try to make my suction line as small as I can, yeah, definitely try to get it as close to the water as you can. When how long you're going to leave it out there, you have to decide what type of battery you want. The NiCad and the lead acid are the most common that we use. If it's going to be out there for a long time before it actually does the sampling routine, well, then you may want to go with the bigger, 100 amp hour and stuff like I said before. So programming, is different for each unit. If you have trouble programming or anything like that, you can always give us a call at tech support. We can, help you out with any type of programming that you have or any actually application questions. Next one, where should the sampler strainer be positioned for the most representative sample? So most of the time what we see is basically the bottom middle of the stream is where you want to put your strainer. That can change, based on your flow conditions and everything like that. If you have a lot of silt or sediment in the bottom of the pipe, well, then you probably want to mount it, above that silt or sediment line. If you have one part of the pipe, kind of what we were talking about before, that tends to debris up and stuff like that, well, then you probably want to change that location too. But yeah, what we see most common is the bottom middle, of the channel. When you put them in like a river, I've seen samplers, where they throw the suction line in a river or stuff like that. Basically, the most common thing I see there is they'll take like a fence post and pound a fence post right down in the middle, and then they'll attach that strainer right, to the fence post. I've seen them wire or strap or tape it, the strainer to like a rock or a cement block or something like that, and just throw that, into the river. The most important thing is just to keep that strainer totally submerged underwater. If you don't have it totally submerged underwater, well, then you will probably get air and not water when you're actually sampling. So, can you discuss the different sampling specifications? So all of the different models there, we have spec sheets actually available on our website, which is Teledyne ISCO.com. The most common specs we get is with the head height. The 6712s, you can get a little bit higher head height, pumping vertical distance. You can get up to 28 feet. The avalanche, again, you can get up to 28 feet. All the other ones are like 23, 24 feet is the max on those. If you want a complete list of all the specs, actually go to our website, teledyneisco.com, and you'll be able to find all the data sheets and spec sheets there. So, next one, what are the best ways to keep the sampler nozzle in the weight stream in different types of manholes and flows? Okay, that's what I said before. Like in the streams, you pound a pole in the stream and you can attach it to that. If you're in a manhole, most of the times the flows in the manholes aren't fast enough where our weighted strainer, our poly strainer is the most common one that we have. And that one is weighted and it's usually heavy enough that it just stays in the bottom and it doesn't float or it doesn't go away. It doesn't, go downstream. If you have faster velocities in the pipe, well, that might start making it float, or it start washing it downstream. At that point, you probably want to use some type of clamp and like an anchor bolt and kind of like anchor it down to the bottom of the channel. Again, you always want to get it always so it's underwater. If it's not underwater all the time, then you'll start sucking air, through some of the holes, and then you won't actually get a sample. Next one, what techniques are there to make sure the ice doesn't melt within 24 hours? So ice, a lot of people will actually ice down their samplers, so that it keeps them cold so it doesn't, the bacteria and stuff doesn't die that's in the sampler or whatever they're sampling from. There are little pockets in the base that holds the bottles. Like with a 24 bottle system, there's a big hole in the middle where you can actually pack ice in there, and it has actually contact with the bottles, and it helps keep the sample cold. If you have a portable, or if you have a single bottle configuration, well, there's room usually around the outside edge of the bottles to pack it with ice. What I recommend is to not use ice for that. What I recommend is to use like the gel packs, the reusable, freezable gel packs. Those are usually the best. Then you don't have to worry about the water draining off or the water contaminating your samples or anything like that. Sometimes once that ice melts, you can get those bottles to start floating up, and then you miss the bottles. The ice packs you can usually pack in there really tight, and they tend to hold their ice and their coolness better than ice does. So yeah, gel packs are definitely what I would recommend. Also, the location you put the sampler really has a big effect on how fast everything warms up. You want to try to get it in the shade somehow, try to build a structure over it so it's not in direct sunlight. Direct sunlight, is going to make the ice melt really fast. What are some reasonable options for long-term off-grid auto-sampling refrigeration? So that one, long-term and refrigeration are the main two components of that are going to fight each other. So when we do our avalanche and our glacier refrigerators, what they'll do is they'll actually wait. They won't run the refrigeration on the unit until it actually starts taking its first sample. Once it starts taking its first sample, well, then the refrigeration system powers up and it starts cooling down the sample and maintaining, the sampler, maintaining the temperature in there. Once the program is done, then it actually starts maintaining it on there. Usually, with a 100 amp hour deep cycle marine battery, we will usually get around 24 to 48 hours of battery life out of our avalanche and our glacier. So you'll have about 24 to 48 hours to go out and actually pick up your samples after your storm event or after your sampler has been triggered. If you're talking long term and you need to go more than 24 to 48 hours, well, at that point you just have to increase your battery capacity. You have to probably parallel 2 or 3 or 4 maybe 100 amp hour batteries. The more batteries you have, the more capacity you have, and the longer that your refrigeration is going to last. Anytime you're putting multiple batteries in the field like that, I would always recommend a solar panel. The more batteries, the bigger your solar panel needs to be to maintain that. So, really, you just have to have more batteries. I always like to make sure that you're putting the batteries in parallel. If you put the batteries in series, well, then you'll get too much voltage and you can damage the equipment. So you always want to parallel all your batteries. So that means all the positives go together, all the negatives go together in the same connection. That's what parallel means. Which samplers take a pulse insert? That's an easy one. All of our samplers will take a pulse input. They're all capable of a flow pulse input from the unit. There's different ways of flow pulse inserts that I kind of talked about before. The two main ones we see are a contact closure, which shorts 2 pins with a cable on there. Every one of our samplers does that. And we also have where if the device that's sending the pulse input actually sends like a 12-volt signal, then we use our 12 volt and our ground, and then you can actually send that as a flow pulse input too. But yeah, all of our samplers will do that. Next one is which samplers take an SBI 12 probe, like sondes and probes and pH sensors, level sensors, temperature sensors. That's basically the language that they speak between that and the sampler. The 6712 and the Avalanche actually are capable of speaking the SDI-12. You go into those and you do a scan, it goes out, it looks for that communication, it finds it, and you set up your probes. There are some probes out there that are ISCO ready that you scan it, it's already, boom, it's set up, you're good to go. There's also sondes that are non-ISCO ready, and there's like a manual configuration that you go in. You say, okay, address 1 on this probe is going to be our level, address 2 is going to be our pH, 3 is dissolved oxygen, and you just go in and tell it what each address means. It will work with pretty much any SDI-12 device. So any of those parameters that we bring in, dissolved oxygen, pH, temperature, we can actually trigger samplers based on all of those parameters that come in. So when we say, okay, when my dissolved oxygen gets above this certain point, you can tell the sampler to, start sampling and start taking samples at that point. If it goes below that point, well, then it can stop the sampler team from stopping. So yeah, any parameter that you bring in, you can trigger off of. There's also data storage in there, where if you have our FlowLink software, you can actually connect up to it, and with FlowLink, you can download all that data, and you can get it into like a tabular form or an Excel type form. With FlowLink software, it's a good tool. You can actually do reports, get average, pH, daily, min, max, all that kind of stuff. It's very easy, very good program to do all that. So yeah, so the Avalanche and the 6712 are the ones that do the SDI-12. That's where the 12 comes from as well in the 6712. The 12 means SDI-12 capable. Just a little note there. That's the end of our pre-questions. I think we have a little bit of time. Do we have some more questions we can do, Tori?
Yeah, we've had quite a few questions come in through the Zoom chat function. So let's see here. We've already talked about cleaning up the clogging inside the sampler. I don't know if there's anything else that you would want to, the question was just how can I clean up the clogging inside the sampler? I don't know if there's anything else you'd want to add to that.
But to clean it out, you would probably just, the purge actually will blow out some of that and clean some of the holes on there. I mean, the only way to clean it is to pull it and to just wash it in some warm water, like a steel brush or any type of brush, just to clear out, the holes on there. That's really about the only way. So.
The problem I have is sampling a 45 Celsius temperature is causing peristaltic tubing to stretch tight inside the pump head.
At 45 Celsius, is that what it said? Where's that one at?
Yes.
Yeah, so at 45 Celsius, that's pretty warm. What it probably does is, it probably just heats up the tubing, and the hotter the tubing is, the less, the more mushy it's going to be. It will probably decrease your suction line, and will probably make the tubing not last as long as well. What I would say is to make sure you use our pump tubing. Our pump tubing actually goes through a annealing process that actually makes it harder than anything else that you can buy, just over the counter. So yeah, ours actually gets annealed and will actually probably perform a little bit better in that type of application. If it's out in the sun and stuff like that, that's probably why you're getting that really high temperature like that. Again, a sunshade. Put a sunshade over the unit so we don't actually get that direct sunlight, and then that can help too. If we can't get that temperature down a little bit, well, then you're just going to have to schedule maintenance probably more often and change that pump tube, more often. So.
The next question I have is, what is the total expected lifespan of a NiCad battery? We have some that are 5+ years old, and I'm not sure I can trust them anymore.
Yeah, so I covered that a little bit before. Typically we'll get about 100 samples out of there. If you find out that you're not getting that many samples with that, then it's probably, the battery is probably bad. I would say probably 5 years, anywhere from 3 to 5 years is probably a typical, lifespan on that. A lot of that is dependent on, you know, how well you maintain the batteries and how good you're charging them. Again, like on the NiCads and the lead acids, you want to definitely charge them at least 16 hours. If you're short cycling them and not charging them as much, well, then they're not going to last as long. You know, they're not, the NiCads and stuff that we use are not supposed to develop a memory and everything like that. I'm skeptical if that's true or not. You know, short cycling is just not good. Also, another way to make them last longer is you probably want to discharge them as much as you can. So let's say you only took like 20 or 30 samples during the routine, so you probably got a lot of capacity left in that battery. So before you actually charge it again, I would probably just run the pump, run a couple of other sample routines, get it down so the pump starts sounding a little bit labored. Once the pump starts sounding labored, that means that the capacity is drained for that. And at that point, put it on the charger for, you know, at least the 15 to 16 hours. So, and you will get a little bit longer life out of there.
Great. The next question I have a 6712 CI modem with a 6712 sampler. What is the advantage of an unrestricted static IP address versus a dynamic IP address?
Okay, so on the 6712, it's not quite as bad. We have other modems where it's a lot more beneficial to have a static as opposed to a dynamic IP. So a static IP address is like is an IP address that stays the same. It never changes. So you can always you use that IP address through our FlowLink software, and you can actually call the unit up, download data, and access it remotely. If you have a dynamic IP address, well, every time it makes a connection, you know, every time the cell phone makes a connection to the tower, it actually changes the IP address. So you actually don't know what that IP address is. So usually you cannot access that, and so you can't call it and, you know, make programming changes. You can't call it to start a program and stuff like that. The 6712, we really have a little bit of a way around that. The 6712 actually, you can power it so it actually is always powered up all the time, and it's looking for incoming text messages. One of the text messages you can send with a dynamic IP address, you can say, you can do 6712 status. And at that point, the sampler responds to you, and in that response, it will actually have the dynamic IP address that you can actually call it with. So you use that IP address that it responds with, and then you can actually call it. So the 67 is unique with that and the modem, where you can actually figure out what that is. But yeah, so it is an extra step on there if you have a dynamic IP address where it changes. So yeah, we always recommend to get the static. That way, it's less problems, and it's more reliable communications with it too. So.
Okay, we just have two more questions that we'll quickly get in here. The next one is, we have a 3700 connected to a 2105 CI interface module and a 2110 ultrasonic module. When trying to use the STORM program for sampling to begin based on the level from the ultrasonic sensor, we had an issue when using the delayed start. The sampler started sampling at the delayed start time, even though the level was below the trigger value. Could this happen if latch is set under sampler enable?
The latch function, what it does is, whenever you meet that condition, whatever your level condition, your flow condition is, whenever it meets that condition, it latches the sampler enabled, or it latches the program running. The other opposite of that is we have toggle. So if it meets the condition, it enables the sampler, and when that condition is no longer met, then it disables the sample. In the latch function, basically, we only look for one time for it to actually, you know, meet that condition. When it meets that condition, then it starts the program, and it starts it running on there. And then basically just runs the whole sample program until it's out of bottles or out of time, or, you know, however you have it programmed. Basically just runs the program till its end. The 2005 can be tricky sometimes programming. Sometimes you can program it to not look at the right flow rate. Sometimes you can program it to not look at the light, or Sometimes they don't select the right rainfall. There's a whole bunch of stuff on that, but I wouldn't think the latch and the toggle feature would be causing that. If it did, you want to make sure that there's a button in there when you're setting up the sampler and the sampler tab in the 2105 that says reset the latch. So you want to make sure to reset that, after the condition has been met. Otherwise, yes, it probably could start the program, right away again. If you want, that's kind of a specific technical question. I would recommend calling the tech support guys on that. The number for that, if you have any questions or anything after this, that number for that is 866-298-6174. That's our direct to tech support, direct to all our application specialists. They can maybe delve into that a little bit further with you and try to figure out, what's going on with that one. So.
And the last question we'll take today is, are you aware of anyone who has used ISCO automated samplers long-term off-grid?
Yes, we have the USGA, U.S. Geological Society. They use them long-term off-grid all the time. They're sampling remote streams and stuff like that. I was talking to a guy the other day that he kind of he was having an issue with the site or something like that, and he said he has to, pack in on horseback, and it takes him 2 days. He has to camp a couple days and then get to the site, and he has to haul in everything with mules and everything. So yes, very remote sites. That happens all the time. The main thing on that one you got to remember is you got to have bigger capacity batteries, depending on how long you want to do it there, and solar. The solar panel, that's definitely what you need to. That maintains the battery, until your event happens, and it gives you enough time to get out there, to the unit. So the main thing is, you want a big battery capacity for that. So.
Great. And I think, Jeff, if you go ahead and click through to the next screen, it does provide contact information as well. So if there are any follow-up questions, comments, or concerns that you guys want to discuss specifically with the Product Support Specialist Group, there is contact information along with what Jeff said earlier. Again, this is being recorded, so it'll be available through Teledyne ISCO's YouTube channel along with all of our previous webinars. So be on the lookout for that later on this week. And I wanted to give a big thank you to Jeff for walking through all these questions. Hopefully everybody's walked away learning something, and information on our September water webinar will come out early next month. And with that, I want to thank everyone for joining us, and have a great rest of your day.
Thank you, everybody.
Thank you.